So, good evening to each and everyone. So, in this segment in physics, we'll be looking at heat calorimetry. What is heat? Heat is the energy that is transferred from one place to another due to the temperature difference between the two bodies. So, once there is difference in temperature, then there will be heat transfer, and that heat is energy. Then, in this heat calorimetry, one of the first things we'll look at is what we call the heat capacity. Heat capacity is denoted as capital C. Heat capacity, actually, it is the energy that is required to change the temperature of a substance by 1 degree Celsius or 1 Kelvin. So heat capacity, yes, heat capacity C is equals to the heat energy that is required to change the temperature of a substance. So let's call this one equation 1. Heat is measured in joules. Change in temperature will be in Kelvin. So the SI unit is joules per Kelvin. That's the SI unit of heat capacity. Then the next one we have is specific heat capacity. Specific heat capacity. That's small c. Specific heat capacity. That word specific because it deals with an intrinsic mass. That means a unit mass, a mass of 1 kilogram. Specific capacity is defined as the heat energy that is required to change the temperature of a unit substance, to change the temperature of the unit mass of a substance by 1 degree Celsius or 1 Kelvin. So specific capacity is the heat energy that is required to change the temperature of a unit mass of a substance by 1 degree Celsius or 1 Kelvin. This will be our equation 2. But from this equation 2, we discover that specific capacity can be 1 over mass. Yes, that dot means multiplication, multiplied by Q over delta theta. So from here, I'll have C equals to 1 over M multiplied by C over delta theta, Q over delta theta. This is it. So which means in the place of Q over delta theta, I can write big C. So in that case, specific capacity will be heat capacity per unit mass. We can call this one equation 3. But from this equation 3, if we make C the subject of the formula, heat capacity means mass times specific capacity. Let's keep it as our equation 4. Then I want to get the SI unit of what? Specific capacity. Getting the SI unit of physical quantities in physics is very easy. And remember, in physics, yes, a quantity, that's a physical quantity without a unit is improper unless that physical quantity don't have any SI unit, like mechanical advantage, velocity ratio, and so on and so forth. Apart from those things, yes, a physical quantity in physics is being accompanied with a unit. So whenever you are given a question, yes, and maybe you solve a question, your current is 2.5. That will be 2.5 amperes. If it is force, 2.5 newtons, and so on and so forth. So I want to get the SI unit of specific capacity. How do I get the SI unit of specific capacity? I'll get the SI unit of what? Energy, which is joule. The SI unit of mass is kilogram. SI unit of change in temperature is in Kelvin. So if I carry these things up, this is joule actually. This is kg to the power 1. If it goes up, it becomes kg to the power minus 1. Kelvin becomes Kelvin. So the SI unit of specific capacity is joules per kilogram per Kelvin. Joules per kilogram per Kelvin. Then, what happened now is that from this equation 2, from equation 2, C is equals to Q all over M delta theta. This one is a fraction. I can make this one a fraction by dividing it by 1. Then I'll cross multiply. 1 times Q will be what? Q. C times this will be MC delta theta. This is equation 5. But remember, MC is this MC that is here. So in the place of MC, I can put capital C. So which means energy can still be heat capacity multiplied by what? Change in temperature, which is equation 6. So here we are saying Q is equals to MC delta theta, which is still the same as C delta theta. Take note, where our Q actually stands for what? The Q actually is heat. And that heat actually is energy. Or heat is the energy that is transferred from one place to another due to the temperature difference between two bodies. Then what do we know again? I think Delta theta actually is the change in temperature. That's change in temperature. M actually stands for mass. Okay, so from there we are going to move on to the next segment. So after this, now the next thing we are going to look at is what we call latent heat. The word latent heat means hidden heat. Latent heat means hidden heat. Latent heat actually is the heat energy that is required to change the temperature of a substance without a change in air. That's the heat energy that is required to change the state of a substance without a change in air temperature. So that word latent heat means hidden heat. In other words, it is invisible heat. The thermometer cannot detect it. Some school of thought define latent heat as the heat energy that is supplied to a body or absorbed by a body that causes a change in state without a change in temperature. So whenever you are being asked to define anything latent, just know that that definition will end with what? Without a change in temperature. Because latent heat means, yes, heat energy that is required to change the state of a substance, but without a change in temperature. So let's write them down, then I'll define them. So before I continue, if actually you are new to my YouTube channel, please do ensure that you subscribe. You click on the subscribe button. Then you can also follow me on TikTok. Yes, using this link, Master P 2023. Yeah, so let's continue. So we have latent heat. So call it latent heat. That word latent means hidden. Yeah, so we can call it latent heat or hidden heat, just as I said. There is a heat energy that is required to change the state of a substance without a corresponding change in temperature, or it is the quantity of heat that is supplied to a body or absorbed by a body that causes a change in state, but without a change in temperature. Now let's look at some definitions. We have what we call fusion. Fusion is a process whereby substance changes from the solid state to the what? Liquid state. Yes, when the substance changes from the solid state to the liquid state, that thing is called fusion. Or vice versa. When the substance changes from the solid state to the liquid state, or vice versa. For example, the melting of ice cream is fusion. The freezing of ice cream is fusion. So fusion absorbs two processes. Fusion can be as a result of melting. Fusion can be as a result of what? Freezing, which is an example of a physical change. Because a physical change in chemistry is a change that is easily reversible and no new substance is formed. So freezing of ice cream is a physical change. The one you keep, if there's no power supply, it will melt. So melting is still a physical change. So melting and freezing brought together still gives us what we call fusion. So there's a difference between fusion and latent heat of fusion. Latent heat of fusion. Yes. Latent heat of fusion, yes, it is the heat energy that is required to change the state of a substance, yes, from solid to liquid or vice versa, without a change in temperature. Remember what I said? Once the word latent comes in, that definition must end with without a change in what? Temperature. So without a change in temperature at its melting point. So I repeat the definition. Latent heat of fusion, it is the heat energy that is required to change the state of a substance from solid to liquid or vice versa without a change in temperature at its melting point. There's a difference between latent heat of fusion and specific latent heat of fusion. You know, this topic is full of definitions. So there's a difference between latent heat of fusion and specific latent heat of fusion. Let's write that one down. Specific latent heat of fusion. That word specific means they are dealing with a mass, a unit mass, a mass of 1 kg. So look at the difference between this definition and this definition. It's just because of that 1 kg. Specific latent heat of fusion is defined as the heat energy that is required to change the state of a unit mass of a substance. Yes, from solid to liquid or vice versa, without a change in temperature at its melting point. Then take note, the temperature at which fusion, the melting point of the solid, the temperature at which fusion occurs is known as the melting point of the what? Yes, the melting point of the solid. Then there's what we call vaporization. Vaporization is a process whereby a substance changes from the what? Liquid state to the what? Gaseous state. That's vaporization. Then it's different from. Then, but before I continue, this specific latent heat of fusion here can be getting as maybe it can be given. You can have it as Q equals to mLF. Then the specific latent heat of fusion is the heat per unit mass, and the SI unit is what? Joules per kilogram. They'll have latent heat of vaporization. Vaporization. So latent heat of vaporization, actually, it is the heat energy that is required to change the state of a substance from liquid to gas without the change in temperature at its boiling point. They will have specific latent heat of vaporization. Specific latent heat of vaporization. Specific latent heat of vaporization, actually, it is the heat energy that is required to change the state of a unit mass of a substance from the liquid state to the what? Gaseous state without a change in temperature at its boiling point. And the temperature at which vaporization occurs, the temperature at which vaporization occurs is known as the what? The boiling point of the liquid. The temperature at which vaporization occurs is known as the boiling point of the liquid. So from here we have Q equals to mLV. So which means specific latent heat of vaporization is the heat energy per unit mass, and the SI unit also be joules per kilogram. So that's what we have in that aspect. Then another thing again we are going to consider now is difference between evaporation and boiling. Yes, differences between evaporation and boiling. You can take it in a tabular form. Differences between evaporation and boiling. So let me write here evaporation, and here is boiling. So actually, in the case of evaporation, actually, here, substance that in the case of evaporation is changed from what? Liquid to what? Yes, the substance changes from what? Liquid to gas. There is no, it occurs at all temperatures. The process whereby the substance changes from what? The liquid state to the gaseous state below the boiling point. But in boiling, it is the change from what? Liquid state to the gaseous state at the boiling point. Evaporation occurs at all temperatures, but boiling occurs at a specific temperature. Wind assists evaporation. wind has no effect on boiling. And evaporation occurs at the liquid surface, but boiling occurs at the entire volume. Yes, it occurs at the entire volume, yes, of the what? Liquid. So those are some of the basic differences between evaporation and boiling. I'll repeat again. Evaporation actually is a process where substance changes from the liquid state to the gaseous state below the boiling point. But boiling, the process whereby substance changes from the liquid state to the gaseous state at the boiling point. Evaporation occurs at all temperatures, but boiling occurs at a particular temperature. Yeah. And here the pressure here is not fixed, but the pressure here must be what? Fixed. It does not depend on pressure, but boiling depends on pressure. Evaporation occurs at the liquid surface, but boiling occurs at the entire volume of the liquid. Then wind assists evaporation, but wind has no effect on boiling. So that's it. Then the evaporation depends on what? Surface area. But boiling does not depend on surface area. Because in evaporation, the larger the surface area, the faster is the rate of evaporation. Yeah, but this one does not depend on it does not depend on that. Then there's also effect of what? Boiling point. There's what we call effect of what? A boiling point, or effect of what? Pressure at the what? Liquid surface. Now, when you increase, that's if at all the pressure is higher at the liquid surface, then boiling increases. So that's effect of pressure, yes. That's effect of boiling point at the what? Liquid surface. Now, then there's what we call the effect of impurities or dissolved substances on boiling point. Presence of impurities or dissolved substances, yes, in a liquid increases the boiling point of the liquid. That explains why sea water cooks food faster than ordinary water. Because sea water contains some dissolved salt and will not boil at 100 degrees Celsius. Because water that is free from impurity will boil at what? 100 degrees Celsius. That is the boiling point of water. Ordinary water without impurity. Then the freezing point or the ice point. So this is the ice point of water is 0 degrees Celsius. So water that is free from impurity boils at 100 degrees Celsius, freezes at what? 0 degrees Celsius, giving us a fundamental interval of 100. And what is fundamental interval? The difference between the boiling point and the freezing point. So the boiling point of water is 100. The freezing point is what? 0. So 100 minus 0 is 100. So the fundamental interval of water is 100. Then the fundamental interval of ethanol is 193. Why? Because ethanol, the boiling point of ethanol is 78 degrees Celsius. Then the ice point of ethanol is minus 115 degrees Celsius. And fundamental interval is difference between the boiling point and the what? The ice point. So it should be 78 minus 115, which should be 78 plus 115, giving us what? 193. So the fundamental interval of ethanol is 193. So we're talking about effect of what? Impurities or dissolved substances on boiling point. Presence of impurities or dissolved substances in a liquid increases the boiling point of the liquid, then lowers the freezing point. For example, ordinary water boils at 100 degrees Celsius, freezes at 0 degrees Celsius. But if you put some dissolved substances in a, you can use it as an experiment. In one of maybe the vessel, one of the vessel, you just put water free from impurity. Then in the other one, you take something like maybe salt, you place it on it, you place them in the what? Freezer. You now notice that, yes, or maybe you want to boil them. You put them on two separate, you put them on two separate, maybe pots. The one without impurity will boil at 100 degrees Celsius. But at 100 degrees Celsius, the one with impurity has not even started boiling, because presence of impurities or dissolved substances increases the boiling point of the liquid. Then conversely, if you put those liquids also in a vessel, you put them in a freezer. Yes. Around 0 degrees Celsius, the one free from impurity, it becomes frozen. But at 0 degrees Celsius, the one having impurity has not yet started even at all, because presence of dissolved substances lower lower the freezing point, of a liquid. For example, if it's water, that's supposed to freeze at 0 degrees Celsius. Even at minus 10 degrees Celsius, maybe I've not even started becoming frozen. So presence of impurities or dissolved substances increases the boiling point of a liquid, then lowers the freezing point. That explains why when you go to Europe during the winter period between December and March, you see that there will be snowfall and will cover the road. There are personnel that are being paid. They are pouring liquid salt on the road, on those icebergs. What's the essence of that liquid salt? The liquid salt helps to lower the melting point. That is the first thing. When it lowers the melting point, then those things, those icebergs will melt faster. Then, because salt was used, the road will not be slippery. It will increase the friction between the surface of the tire of the vehicle and the tire of the road. So that's why liquid salt is being spread on iceberg on the road. One, so as to lower the melting point for the ice to melt faster. Secondly, to increase the friction, between the surface of the tire, and the road. So please, that's where we are going to stop here for today. But my lecture is going to continue. Yes, the lecture is going to continue around 9:45 p.m. Yes, on TikTok. We'll be talking. So they will be talking about chemistry. We'll be talking about calculation in chemistry. Then those of you that like what is going on, my niche is all about sciences. I always talk about sciences: biology, chemistry, physics, maths, further maths, physics, chemistry, mathematics for university undergraduates. So that's what my niche is all about. So if you like what is going on, you press on the subscriber button. You can watch my videos. You comment on the videos. If you have some issues, then you can DM me. Yes, or you can still be, you can meet me on TikTok. Yes, then we'll still talk more better. So I'll be live on TikTok around 7 p.m. Around 9:45 p.m. talking about calculations in chemistry. So this is the link. That's the link. So that's my TikTok link, Master P 2023. So if you have any questions, please, you can drop it on the comment section. Yes, then if you still want me to assist you, if you're having some difficulties in physics, chemistry, maths, further maths, you can also DM me. So thanks for maybe watching my live stream. Do have yourself a beautiful night rest. Then those of you that are interested in maybe knowing what calculation in chemistry is all about, all this solubility, mole concept, gas laws, balancing of chemical equation, then you now meet me. Yes, you meet me on TikTok, yes, with this link. Yes, the time will be 9:45 p.m. By 9:45 p.m. today. So I'll be live on TikTok explaining what chemistry is all about and how you can easily work them and do those balancing of chemical equation, do calculations in chemistry without the use of calculator. So thanks and stay blessed. Bye. Okay, yeah, so let me answer. Somebody asked, what is the boiling point of mercury? That is, yes, that is 357, please. The boiling point of mercury is 357 degrees Celsius. That's the boiling point of mercury. So, Nikki the Sapien, I think I've answered your question. The boiling point of mercury is 357 degrees Celsius. So, Olisakwe, you are asking what is the difference between heat and temperature? Heat is the energy that is transferred from one place to another due to temperature difference. Why temperature is defined as the degree of hotness or coldness of a body. But if we are defining temperature based on the kinetic theory of matter, temperature is defined as the average kinetic energy possessed by the molecules of a body. So I repeat again, difference between heat and temperature. Heat is the transfer of energy, yes, between 2 points as a result of what? Difference in temperature. As a matter of fact, people usually use it at times as a song. That heat is the energy transfer from one place to another due to the temperature difference between them, which means heat is the energy that is transferred from one place to another due to the temperature difference between two bodies. But temperature is defined as the degree of hotness or coldness of a body. But according to the kinetic theory of matter, temperature can be defined as the average kinetic energy possessed by the molecules of a body. Thanks for watching my YouTube live stream. See you tomorrow. Then those of you that are interested in learning calculation in chemistry, yes, I think you meet me by 9:45 on my TikTok channel. This is the link. So Master P 2023. Bye.